we start to work on practice questions of chapter 2. In my personal opinion, practice questions is the most important part of learning this course, at least one of the most important parts of learning this course. It gives you an opportunity to evaluate your learning outcomes. If you feel okay, feel comfortable with practice questions, that means you will do definitely okay on the exams. So here we go. We are going to solve some practice questions from the textbook. The first one we try is 2.2. So the first question is 2.2. Paul expects to receive payments of 1,000 at the end of each year for 5 years, with payments to start 1 year from now. Howard expects to receive payments of X at the end of each year for 10 years, with payments to start 1 year from now. So both will start 1 year from now, so it's a standard annuity immediate. At an annual effective interest rate of 5%, the present values of their cash flows are the same. Determine X. Okay, so we have two people down here. One is Paul, the other one is Howard. Each person receives annuity immediate with different terms. The first one is for 5 years. The second one is for 10 years. So the present value of 10 payments at the interest rate of 5% equals X times A angle, here's 20, 5%. So we are trying to calculate X. Their cash flow, the present values of their cash flows are the same. That's why I have this equality. Okay, both of them start 1 year from now, so it's annuity immediate. That's why it's A, not A double dots, not A bar. In order to calculate X, this should be easy. I leave this to you. If you want to check, the result should be $560.69. That is the first question. The next one is 2.3. Starting now, Matt receives payments of 20 at the beginning of each of the next 3 years. Starting 3 years from now, Matt receives payments of $10 at the beginning of each of the next 3 years. The annual effective interest rate is 8%. Calculate the present value of those payments. For this question, you definitely should draw a timeline. 1, 2, 3. For the first 3 years, Matt receives a payment of $20. Okay, so here 20. So this is the beginning of the first year. Here is the beginning of second year. Here the beginning of third year. Okay, so basically this is an annuity due of amount $20 for 3 years. And then things changed. What changed is the amount. The amount is not 10. So let me put a different color. Okay, starting from the fourth year, the amount is not 20. It becomes $10, and it also lasts for 3 years. So the next 3 payments are at 3, 4, 5. Okay, So basically, we have 6 years. All the payments are received at the beginning of the year. So it goes from 0 to 5. For the first payments, the amount is 20. For the next 3 payments, the amount is 10. So there is a change of amount. So technically speaking, you can think this as annuity with varying payment, right? So this is not exactly level payment. Um, there are actually many ways to solve this question. What we want to know is the present value. Is how much is this worth, right? Again, what is the dumbest way of solve this question? So start with something all of you can understand. There are only 6 payments, right? How hard could it be to directly calculate? So once I finish writing, all of you probably understand why I have this summation, right? So all I'm doing is simply I discount each by each. The first payment is received at time 0. There's no need to discount. So $20 is $20. For the second payment here, it's received in 1 year, so I need to times by V. The second one is at 2, so I discount by V squared, etc. Right? So you see how you can calculate what is V. I know the effective interest rate is 8%, so V is 1 divided by 1.08. This is the dumbest way of solving this equation, this question. And technically speaking, it's not exactly dumb because there are only 6 payments, right? And you are allowed to use calculator for the exam, for SOA exams, right? So just punch the numbers, right? So this can be done in less than a minute, right? Does not require any understanding of annuities. But that's not what we are trying to do. Obviously, we want to do something different. So the next, let's think the first 3 payments as an annuity due. So I have 3 payments at I being 8%. Okay, then I will try to handle the second term. The payments in blue, you can think them as a deferred annuity, right? Or it can be a deferred annuity. Let's also call it annuity due. So if it's annuity due, then first of all, I have 3 payments at 8%. If I think this as annuity due, my starting point is 3. So when I discount back, I need to discount by 3 years, right? So from here, you can apply the formula to calculate. So in the end, you will see that, right? So if the number of payments is relatively few, like in here, we only have 6 payments. The dumbest method is likely the smartest method. It takes probably less time than any analysis, right? But nevertheless, I will teach you how to analyze this because sometimes for the SOA questions, the number of payments is just too big, right? Let's say for the first 20. For the first 20 years, Matt receives $20. For the next 40 years, he receives $10, right? In that case, if you are trying to apply the thumb method, it's going to take maybe 5 minutes to get everything done. And any calculation mistake could cost you everything, right? So that's why in that case, method 1 is somehow not suggested. But for a question like this, method 1 is actually the preferred method. There are so many ways, right? You can also treat the second one as a standard annuity. So let's treat the first 3 as an annuity due, but now I don't treat the next 3 as an annuity due. I treat it as annuity immediate. If I treat them as annuity immediate, it will start at 2 years, right? Because it starts at 2 years, so I discount by V squared, not V cubic, okay? What's more? What more can you think of? The fourth method So what I do is I depackage $20. So I write $20 as this, 20, 20, 20. I have 20, 20, 20, 10. So I write 20 as 10 plus 10. So by writing this, what I have an annuity due of 3 payments. So I'm taking care of these 3 guys, right? Okay, I also have another annuity due. The payment's still 10, but now I have 6 payments. So the next one handles these guys, right? So this is very, very hopeful idea when we move further on, when we study something more complicated. This is basically depackaging everything. Okay. So here it's I did a little trick by separating the first 20 the first three $20 into 10 plus 10. So I can easily package them into 2 different annuity dues, right? And then everything becomes easy. There are actually many ways to do that, right? I mean, what else can you think of? I mean, this goes on and on, right? You see, when you study annuity questions and when you start to understand everything behind it, there are just so many different formulas, right? Right now, I keep 20, 20, 20, 20. Originally, the next 3 are tens, but I don't like tens. Okay, I want them to be 20. Okay, in this case, I borrow, right? If I borrow, I will need to subtract back. So I use this color to denote they do not belong to me. So eventually, I will need to subtract this part. But nevertheless, we can think this as, so now I have 6 20s. So it's an annuity due, but now I have 6 instead of 3. Okay, but please remember to subtract back three payments, right? Okay, so for those 3 payments, you can think them as annuity due if you want. So then I have 3 payments. If I consider them as annuity due, the starting point is here, right? So it will be 3. So I discount back by 3 years. I can also think those 3 So I can also think those 3 as annuity immediate. Then it's still the 3, but I'm going to remove double dots. And when I discount back, is not V cubic, it's V squared, right? Like here. So there are just so many ways to understand. This is just a quick example to show you once you truly understand the time value and you understand how to draw a timeline to help you analyze, there are usually many ways to solve annuity questions. Next one, 2.4. In 2.4, we starting today, Sandy sets aside $10,000 at the beginning of each year into a bank account that pays an annual effective interest rate of 5.5%. She makes 25 such deposits. 30 years from today, Sandy uses the accumulated value in the account to purchase an annuity that pays X dollars at the beginning of each year for 25 years. Determine X. This is a very interesting question, and it's common to see this type of questions from the actual SOA FM exam. Though basically here, the idea is Sandy first makes deposits into an account. In that phase, the account accumulates value, right? So once this phase is finished, she starts to withdraw money from that account until the account is fully depleted. It looks like a pension, right? So when you are working, you start depositing money into the pension account. And once you retire, you start to withdraw money from your pension account. This is basically what Sandy is doing in question 2.4. Okay, starting today, starting today, starting today. So deposit how much? 10,000. So that's a lot of money. So Sandy sets aside 10,000 at the beginning of each year. That's why I put 10,000 at 0, because that is the beginning of year 1. She will continue doing this for 25 years. So the last time she deposits will be at 24. 24 is the beginning of the 25th year. So this is the last time she makes a deposit of $10,000 into this account. So obviously here we have 25 deposits, right? From 0 to 24. So you have 25 deposits. The interest rate, effective interest rate is 5.5. 30 years from today, 30 years, Sandy uses the accumulated value in the account to purchase an annuity that pays X dollars. So from this point on, she can take out X dollars again at the beginning of each year for 25 years. So here she will withdraw 25 times. Okay, so how do we analyze? So first of all, we have, there are different ways to do it. So here you do the accumulation first. When you do accumulating, this is a annuity due. So when you look at this, let me use a different color. So this is the end. 25 is the end of depositing. Okay, so if you see this as a annuity due, what is the future value at this point? So I use this color. So let's say whether you agree. Remember, it's an annuity due, so the future value is S double dots. According to our notation, this is exactly the value at, this is the value at 25 years. Okay, so which means it's here. So this is the accumulated value of Sandy's account at time 25 years. At the end of 25 years, she will have this amount sitting in her account. But this is not when she starts to withdraw money, right? She begins withdrawal at here. So how many years between those two? So if you are not sure, right, this is a relatively short period, right? So you can actually write down. So here 26, 27, 28, 29. How many? 1, 2, 3, 4, 5. Right. So you accumulate by 5 years. So now I am sitting at 30. Okay. So now the value after accumulate by 5 years, I'm sitting at a time 30 years. And this is another annuity due, right? Because it's paid at the beginning of each year for 25 years. So the last part will be my withdrawal. So X, I don't know, so I keep. This is annuity due. Because it is annuity due, so when I calculate my present value, it is when I receive my first payment, that is time 30 years. I will receive 25 payments, so angle N is angle 25. the interest rate is still the same. Okay, so this is the analysis. This is everything you need to do before you establish the equation of values, right? So this is not exactly present value or future value, right? So this is basically you are equating values at the same time point. On the left-hand side is the present value, right? It is the present value at time 30. On the right-hand side, excuse me. On the left-hand side is actually the future value, right? Relatively speaking, but still at the same time point 30. So long as you are talking about at the same time point, you can equate them. Okay, that's why once I get this amount, I cannot equate them because this amount is at 25, not at 30. That's why I need to accumulate for another 5 years in order to get to the value at time 30 years. Okay, this is really, really important. Um, from here, the rest is not is not complicated, right? Please do not do all the computation. Here, there is a lot you can simplify because. So what is future value? What is the difference between future value and the present value? It's 1 plus I raised to the power of n. So then it becomes the present value. Okay, so here's 1 point, let's keep this. So once you notice this, cross them out, right? It saves you so much time, right? So what is x? That's everything. It's really interesting, right? Because the term of both annuity dues, they are the same, right? You use 25 deposits to finance 25 withdrawals, and the interest rate is the same. So what would change is basically, if you think of it as this way, uh, I use the let me draw a different graph. So what I'm going to draw in this graph is the true understanding. Once you understand this, you don't even need to list anything, and you can see the result. Okay, so at time 0, Sandy deposits $10,000, right? And she will continue doing this 25 times. Okay, so the idea is very straightforward. The first deposit is used to finance the first withdrawal. The second deposit is used to finance the second withdrawal. So etc. goes on. The last is used to finance the last withdrawal. So if I put down $10,000 at time 0, how much it is worth at the end of 30 years is the deposit amount times AVF of 30, right? This is exactly AVF of 30. So 2.4 is very interesting. You can do the standard like this. This is the standard way of solving it. This should be every one of you should be doing. That is, writing down the equation of values and try to solve it. But please do not calculate this, okay? Spot the relation between them, and that will save you probably 1 minute. If you have a deeper understanding, then this question you should be able to write down this directly, right? If you understand the true meaning of financing, right? The payment from 0 is used to finance the withdrawal at 30. The deposit at time 1 is used to finance the withdrawal at 31st, etc. Right? So each payment or each deposit is used to finance the withdrawal 30 years from the deposit. So this is the result. Okay. let me pause here and continue in the next video.